Day 3 of CERAWeek from IHS Markit. 3 takeaways. Radiative cooling, Orphan Software, and satellites tracking methane. First one, radiative cooling. It was a great session from Professor Stephane from Stanford University yesterday. It's titled Harvesting the Coldness of the Universe. Now I'm way oversimplifying this, but think of all the energy we get from the sun every day, and at night time a lot of that energy is radiated back out to space. They've developed materials that can do that same process and radiate back energy, if you like, during daytime. And not only that, what they've also developed is some technology where using a thermoelectric generator in the same material, they're able to generate electricity as that thermal radiation is happening at night time. Now, when you think of the amount of energy that's radiated back into the coldness of space every night, almost equals the amount of energy we get every day from the sun. Can you think of the potential for this thing? Fascinating. Second one, Orphan Software. This came up in one of the digitalization sessions yesterday. It was Brandon Spencer from ABB came up with the point that as we deploy more Internet of Things, industrial Internet of Things, digitalization, there's a lot of individual boxes and pieces of software that go out there into existing infrastructures, and they don't talk to each other very well. The interoperability is poor. Now, if you're building something brand new from scratch, you can kind of think about that ahead. But if you're brownfield or whatever, there's a lot of point solutions out there that don't play well with each other. And he called it Orphan Software because it's hard to keep track of it and cybersecurity risk and whatever. I hadn't heard that term before. Great one. Orphaned Software. Last one. Satellites tracking methane. There was a session from the CEO of GHGSAT, Stephane Germain, talking about what they've done with the constellation of 3 satellites they have and how they track methane emissions from their satellites. Now, not only that, but they're taking the data from the European Space Agency's Stephane satellite, or sensor that's on one of their Sentinel-5 satellites, and incorporating that data and other sources. And what they've published since last October is an online map of the world showing almost, weekly or daily updates of the methane emissions on the planet at a 2 kilometer by 2 kilometer resolution. Now, they're taking data from the Stephane, from the which is a large, let's say it's something like a 7 kilometer by 7 kilometer square. The GHG satellites are far more accurate, but they cover a less area, but they do it down to 30 meters by 30 meters. And by combining all this, you can actually get a view from space of methane emissions. Now, there's a lot being done by the oil and gas industry to try and stop some of these, but they're still venting and flaring and fugitive methane emissions. So imagine just being able to watch this in almost real time and see who's doing what really. That's fascinating. And there's a lot more satellites. GHG are planning more, European Space Agency, Methane Sat in the US, and. So tracking emissions from space, interesting. Anyway, that was day 3. On to day 4.